Alright guys, welcome back. So let's talk about port security. And by port security we will be talking today what are the options that you have with Red Hat Enterprise 7 to protect the daemons in your server. Basically just to make sure that when you're running a service like a web service or DNS or email or something like that, SSH, you allow for access to those services only to whatever is supposed to allow to access it. The idea is to reduce as much as possible the attack surface on your server. So you want to make sure that your server is as restrictive as possible, so you don't have to you don't give opportunity for intruders to attempt anything on your server, because anything can bring down your server. If they don't break into it, at least it could come up with a denial of service and basically make your server unusable. At the end of the day, you cannot block everything, so you have to allow something, right? But the point is that we want to make sure that you have the tools to allow only what it's required, right? And on that note, we will talk about some of the options that we have in Red Hat. So the first one, first we're going to talk about the toolbox as usual. So I'm going to give you all the tools that you need to complete the task that we're going to talk about today. We're going to get there in a minute, and then we will talk about security enhanced Linux port labeling. So we will see how security enhanced Linux has policies that use the labels on predefined ports to establish what ports can be used for a particular service, right? So they are predefined ports for SSH, predefined ports for HTTP. So if you try to use a port different than the ones that are already defined or labeled for those services, then obviously the system will not let the service to create a socket and bind to that particular port in your network. Then we're going to talk briefly about two files, which is the host deny and the host allow. And these two files are used to restrict access very quickly. So this is very easy to use. So I want to just talk about it really quick and show you how to use it. And then we will talk about the firewalld, which is the bulk of the video. The new implementation for Red Hat Enterprise 7, is firewalld. Before we used to use IP tables, and I'm very happy to see that the new implementation is a lot more modular and it's a lot more organized and introduces the concept of zones. And we will talk about zones in a minute as well, and how is zone-based firewall is used to organize your rule set in a way that makes sense. And then we're going to demonstrate some, work with some firewall rules and work with the firewall to show you how you can add ports, allow and deny ports, through your firewall. Then we talk about masquerading, which most of you probably know about, is network address translation. So, as you know, this was a temporary solution to the IPv4 problem, right? We didn't have enough IPv4 addresses. In fact, we already run out of IPv4 addresses. So the concept of network address translation or port address translation or masquerading was introduced to resolve that problem. And obviously, if we're masquerading our local IP address, then obviously we want to use port forwarding for the services that we want to publish to the outside world. So we talk how to configure port forwarding as well. So let's go and talk about the toolbox. So the toolbox, as usual, is the system administrator's guide. So that guide, you get very familiar with it. Go into it. There's a lot of examples there on how to use your file. And then we have a couple of man pages that obviously these are available on every server, right? So you can, if you are taking the exam or you're a customer and you have access to the internet, these are the files that you have handy. The first one is the man page for semanage-port. So we see that that file in a minute. And then the man page for firewalld also is a very important page to get familiar with. Although you probably won't be on that file man page too often, but it's a good man page to go and refresh some of the commands that you can run with your firewall.d or the tool firewall-cmd, right? And then there is the man page called firewall.d.zones, right? We will go through it. It's a very small page, but it's also some good information. And then we have the man page for firewall.cmd. And I will include a second, a last man page, which, in fact, I'm gonna add it here. Well, we're gonna find it. I'm gonna show you how to find it. So, it's the man page that we use to create rich rules. So when we start talking about rich rules, you will see that the syntax is not really straightforward. The firewall-cmd command is tab friendly, and you can avoid making mistakes. But when you configure your rich rules, you might want something that you can use to help you out with that. Okay, so first let's talk about semanage-port labeling. As you remember, we're going to talk, the relevant toolkit is the man page semanage-port. So let's just go ahead and take a look at that page real quick. We're on server 1, so if we say man semanage-port, you will see that you have the man page for SE-Linux policy management port mapping tools. And here you have, obviously as usual, some options that you can run with this tool, but what's important really is the examples that you have right here. So here you have a couple of examples that are very interesting. The first one is the semanage-port -L, which you're going to use it a lot, and this is the one that you use to list all the ports that are the port labels that are available. The second example is one example on how to allow Apache to listen on TCP port 81, and here it shows you how to actually add a label to a particular port. So basically you will use semanage, then port -A to add, and then T for type, and then you have the label type, which is HTTP port T, and then here you have the -P for protocol, and then you specify protocol TCP or UDP, and then you specify the port number. And here you have a second example, which is pretty much the same one, but I would say that HTTP and SSH ports, are very common, right? So these are very good. It's good that the examples are here because you can just copy and paste and use them, as you need them, right? So it's basically the same thing. You use semanage port -A to add, -T to specify the type, and then -P for the protocol, TCP, and then the port number. All right, so let's just use it and go through an example, right? So if we use semanage port, then -L, you see that you get a big list, and then on the left side you have the label, and then you have the protocol, and then you have the port or the list of ports, right? In some cases you have actually multiple ports or port range, that are defined for that particular label. If we wanted to take a look at something that that we're familiar with, we can grep to HTTP, for example, right? So obviously, we give you the labels that you have available for HTTP, which is HTTP cache port T, and then HTTP cache port T as well for UDP in this case, and you have the list of ports there. What's interesting for HTTP is the HTTP port T, which shows you a list of ports. So you have 82, 80, 81, 443, 48, and whatnot. I actually added 82 here, which when I was doing some testing before the lab. So I'm going to we're gonna put it to good use. So you can see we have 82, 80, 81, 443, 48, and then 800, and we have a ton of ports in there. But for example, we don't have port. Let's say 8080, right? So the port 8080 is typical. Let's not use 8080. Let's use because we have 8080 here. Let's use something like 85, right? So let's say that we want our web server to run on port 85. So let's actually do some configuration changes to the HTTP configuration. So let's do. And let's change the port and configure it to listen on port 85. Let's get out of there, and then we do systemctl restart. Sorry. HTTPD. So what's gonna happen is gonna fail, right? So it's saying, HTTP failed because the control process exited with error code, sysintl status. So we need to, it's asking you to do status -L to take a look at what happened, right? Sorry. And then if you see what, the error, let me see if I find it here. First it's saying make sock here could not bind address, and then it gives you the IPv6 address, and then it says port 85, and then it's also saying you cannot bind address 0.0.0 to port 85 either. So what's really happening here is that obviously port 85 is not one of the ports that SELinux is allowing, as for your HTTPD daemon. So you really have to add that port to the list of ports that are available for HTTP. So the way to configure this, the first thing that I will always do, by the way, is just go to the main page and copy copy the information there. But let's first list and look at the label. So the label that we want is HTTP port T, right? And if you can remember, just go for it, but really you do -A to add, -T, and then you want HTTP port. So you should copy and paste that here. I want to misspell it, and then after this you need to specify the protocol, and we say the protocol is TCP and the port is 85. If you do that, then it's going to add port 85 to the list. Let me just list it again, to the list of ports that you have for HTTP port T. Now you have port 85 here, and if we try to start, if we do systemctl start HTTPD, then you see that service now listening on port 85. So status, and you will see service running, and everything is fine. Okay, so let's just test this, right? So obviously the fact that it's running port 85, it doesn't mean that you can access it, but let me see if I have something on the root directory for this web server, and I have a file called index, right? And that file is basically saying hello from server 1, right? So if we do curl and then HTTP column, then we do localhost column 85, then you will see that we have access to that, to that website, which is basically a hello from server 1. Okay, so that's really all there is about SELinux port labeling. It's a very simple concept, and this is all you need to know. But obviously explore the semanage-port man page, and it's not a very long page, but keep it handy in case you need to use it. I want to talk also about the host.deny and the host allow, and this is going to be a very quick discussion, because basically these are two files that are used to restrict any incoming connection to that particular daemon, right? So you will see what I mean by that, but there's two ways to restrict a particular service. The first one is restricting the daemon. If you use semanage, it restricts you from even starting on a particular port, so creating a binding to a port. But if we use the host allow files, what it does, it restricts access to that daemon from external servers, right? And let's say that we want to talk about SSH, right? And before we do anything, I want to take a quick look at my SSH file. So my configuration file, we see SSH, and then we have SSHD config, and you will see that there is, it's listening port 22. So there's no real any configuration on SSH here, but if we go to server 2 and we SSH to server 1, which is 172.16.19.7, you see you have access, right? You put a password, you enter your password, and you're already on server 1. Perfect. So that's, we have access to it. So if we wanted to restrict access just to server 1 from accessing the SSHD daemon, and by the way, we're not filtering yet, this is just to restrict that daemon, then we can edit the etc host.deny. And here, and by the way, here there's some references to some information, right? So let me see, deny option, and then it tells you to use man5 host options to understand the syntax of this particular page a little bit better. But in a nutshell, you can just enter the daemon, in this case SSHD, and then column, and then you specify the host that you want to deny access to that daemon. So 172.16.19.8, which is my server 2. By the way, did I exit? Let me see if I exit out of that server. So I'm on server 2, yes. Okay, so that's basically is gonna restrict access to a particular daemon. This is why this is such a small, this is such an easy concept, right? If you have an issue that you want to deal with very quick, you just toss the host in that file until you can figure out what's going on, right? So right now, if we try to connect, you will see that the connection will be refused. All right, so connection reset by peer, which means it didn't even let me get there. All right, so we go back to the file. We remove that entry, assuming that this was temporary, right? And obviously, very quick, you have access, back to the server. So this is a very handy option to restrict access to your daemons. You could do it with basically anything, with HTTP and any other protocol. But obviously, as I was saying, the tool of choice for your port filtering is your firewall. And I think that most system administrators are very familiar with firewalls. And basically, is you create rules that you use to allow deny certain traffic patterns based on the source, the destination, the port number, or a service, or something like that. In the case of, and by the way, let's talk about our second man page real quick. So the second man page is firewall D. And firewall D, it gives you, some options for the firewall D command. And it talks about some of the directories and some of the services. It talks about zones. What's important is that it has references to the important man pages, to further your configuration. So here, it talks about firewall-cmd, which is your basically your the tool that we're going to use to configure a firewall, and it gives you some, a bit of the syntax, right, for the firewall-cmd. And zone, it talks about services, and here you have also a man page for services, and then at the bottom you have a list of a lot of man pages related to your firewall. So the ones that are more important, from my experience, really obviously the firewall-cmd, which is, we're going to look at it in a minute. And then we have the firewall.zones, which is, we would take a look, but just to understand how zones works and whatnot. And then the rich language, which the rich language man page has all the information regarding the syntax to create rich rules, which you will see they're very, very handy as well. So that's that's the firewall D, and the second man page is the firewall.zones. And let's take a minute here and talk about zones quick. But let me hop into that file, right? So the implementation for the firewall, let me just scroll here. All right, so the implementation for the firewall D is a lot more organized. in the sense that it uses zones to group rules based, you can define a particular rule set for a particular zone. So imagine right now, initially before the concept of zone-based firewalls came in, you would just filter whatever was coming into an interface. So, but imagine if your network scales, very a lot, then you might have multiple networks, and those networks might represent different zones. You might have zones that are very secured and zones that are kind of public, like DMZ and stuff like that. And the zone concept is used to separate those traffic patterns, and so you can categorize traffic first based on the source of the traffic. And obviously, in this file, there's some explanation about what the zones mean, and how they work with an interface, how to assign interfaces to a zone, the syntax to add a source, right, which is basically a source address or source MAC or an IP set, or a service. You can add a service to a particular zone, or a port, or even a protocol, and then obviously a CMD block, and then you can masquerade a zone, and you can use port forward and so on, and we see all those, all of those when by the time we start talking about, we take a look at the firewall-cmd command, right? So it's a very good man page just to take a good quick look. Here you have some rules as well, and this is what we're talking about, rich rules. As you can see, the syntax it can get very very large. But you will see that there's a man page that's a little better for that, right? All right, so let's hop into our last toolkit, which is the man page, and I think this one is the one that you will use the most, right? Firewall-cmd. And firewall-cmd is really this firewall command line client. There is a graphical client that you can explore as well, but again, right, I know that every server will have at least a shell, right? So if I go to a place, to a customer or something like that, and the server doesn't have a graphical interface, then I should be able to use these tools. So feel free to explore the graphical interface for firewall, for the firewall, which is firewall config. But I encourage you to learn how to use the command line interface, because it's going to be very useful. And as usual, it starts with with some options here that we're going to see, how to use them, right? We have the state, we have the reload. We're going to use the reload a lot. And then we have the permanent option, and then we have some zones, right? Some directive for zone. The get default zone, which is going to print out the default zone, right? So, and the interfaces that are assigned to that default zone. So, the default zone really is defined so whenever you enter, whenever there's traffic that cannot be classified, it will go directly into the default zone, right? And whenever there's traffic that, whenever you enter a rule that you didn't specify a zone for it, so it will go into the default zone as well. So it's just to make sure that there is a catch-all in there, just in case, there is some ambiguities, right? So there can't be any ambiguity. So the firewall doesn't just drop the traffic, it just, apply whatever rules to, pertain to particular, to your default zone, right? Obviously, there's an option there to set your default zone and change it from whatever it is at the moment, and that the way to do that is using the set default zone, and we're going to use it in a minute. Then we have the option of get active zones, which is going to print all the active zones that we have at the moment, and it will show you the interfaces and some of the configuration. Right, so you have the option of permanent, right? And I want to stop here and talk about it for a second as well. The firewall has two configurations. One is the persistent configuration, which is the one that will survive your reboot, and then the running configuration. These two configurations are different. So, you will see that if you enter certain configuration in the firewall, the configuration is not necessarily or either active or persistent. So the permanent command is to do persistent changes to your firewall configuration. So using the dash permanent, we show you, what zones are, what rules are permanent for that particular zone, and what rules, and if you don't use the permanent, we show you what rules are active. So we will see that in a minute as well, just to get that distinction out of the way, right? Then we have a few other comments here. Just feel free to look into it. And here's what the the zone will look like, and you will say that it has assigned interface to the zone, source addresses, services that are assigned to that zone, obviously ports, and then protocols, and then port forward rules. Then there are source ports, and then rich rules and ICMP blocks, right? So we'll see how to configure that and what it looks like on the real life. One interesting comment that might show you some good information is the list all zones, right? So this is gonna list everything added for or enabled in all zones, right? So we give you an output that will show every zone and all the configuration they have for every zone. So if you want to take a look at everything that's configured if you're using multiple zones, right? And obviously the permanent will show whatever is gonna survive a reboot, right? You can create new zones, delete zones. There's a ton of stuff here that you can do. Okay, so let me just scroll down because I wanted to talk. Right, so here you have all the stuff that we're gonna use. By the way, a lot of the comments that we will use are here. I will show you anyways, but you can refer to this section here. But one that I use this file a lot for is for the port forward, to understand the syntax of the port forward. So you can see it's a very large syntax. So I want to make sure that I copy from here and then paste it and then use that syntax so I don't make a lot of mistakes. One interesting comment is the timeout. The timeout is, you can define a timeout for that particular rule. So let's say that you're testing something and you by mistake lost access to your server. So the timeout is going to be your savior here, because if you say, okay, I'm going to set this rule and test it for 20 seconds, and if it works, then I enter it formally, but if it doesn't work, I want the rule to timeout and get out of there. So that's what the timeout comment is used for. So you can, at the end of your rule, you can set a timeout, and then the timeout would, once it expires, it would take the rule away in case you lose access, right? So this is also a good tool to have, a good tool to use. Just remove forward, right? Obviously, if you want to remove your port forwarding, and then some queries that you can do for your port forwarding. Okay, so there's other things here that we can do. I wanna scroll down a bit to show you. Obviously, this is a very long file, but you want to be very familiar with it, right? Okay, so you can talk about services, right, which is basically how to work with your predefined services. You can create new services, right? And this is how to work with services. Basically, services basically, if you create HTTP service, you can define a port group for it. So that's what that's for. All right. So anyway, just again, look through this file. Make sure that you look for what you need here. You have some examples, down here that are very interesting as well. So these examples are straightforward. For example, example 1 and 2. The first one shows you how to add a service. So you have firewall-cmd and then add service HTTP, and that's all there is to it, right? So this command is very simple, and if you don't define a zone, it's just going to add to your default zone the HTTP service, right? But of course, if you don't have a service for it and you want to define add a port, you can specify the port / the protocol. And here's an example how to make it permanent, right? And add it to your make it persistent across reboots. Okay, so that's it. So let me see if we have another toolbox that I want to talk about. Right. So no. So let's start, working with zones. So firewall, again, firewall CMD is very tab friendly. So you can tap and it's going to show you. It's going to show you what commands you have available, right? So let's do the first one. Let's do get, and let's get default. Default zone, right? So you can see my default zone is public. Let me just clean this up a bit. My default zone is public. So if I do a list all, you will see that my default zone has already assigned an interface, which is the interface on the server. So basically every traffic coming through that interface, unless it matches a different zone, is gonna be, all the rules on this zone are gonna be applied. So then in services, I have SSH and I have the HTTP client, right? So basically, if you want to change the zone, right? So let's say that we want to change the default zone to work, right? So you can use the set default zone to work. And obviously what that's gonna do is all, then you're gonna have your work zone, and it has, as you can see, the interface was assigned to the zone work, and now you have whatever rule sets are defined for work, right? So let's say that we want to do we want to take a look at minus zone equals public. Let's take a look at public. So we have list all, so we can actually take a look at what's configured for the zone public. So here we have public zone. Now we don't have any interface, right? So the only interface that we have in this server has been assigned to the work zone. So everything, going through that interface is going to be basically work, right? So, but obviously, let's assume, right, that our server 1 is going to be on the public zone. So we can say firewall-cmd, and at this point we want to make our changes persistent, right? CMD, and then zone public. Then we do an add source, and then we have either source port or add source, right? So add source will be to add a source address. So we can say 172.16.19.8/24. Now this source address is part of my public zone. So if we take a look at the public zone, list all, we have that source address here. But that is on the running configuration. If we take a look at the persistent configuration, for that we put the permanent, and you will see that it's not on the permanent configuration. So we need to add it. The way to add it is you take the same rule and you have permanent at the end. Once you tested it and you make sure that everything is working fine, right? So let's say that I want to I have, if you remember, I created a web server on port 85, right? And now server 1, if I do curl http 72.16.19.7 port 85, there's no route to host. What that basically means is that if you take a look at my public zone, we don't have a rule that's allowing that port 85. So to add that port to the public zone, right, we can always say firewall-cmd. We specify the zone, right? Zone equals public, and then add port, right? and then we say 85/TCP, and then we can do a timeout in case we block access, and then let's say there's 10 seconds. So if we look at the permanent, we don't have it on the permanent, but we have it on the running configuration, and I just want to test the timeout. So we got 85, we set 10 seconds. If we do curl now, failed, not routed to host. All right, so what's happening is that the rule already was removed by the timeout. So let's get rid of the timeout. We didn't lose connection to the server. Let's add the rule, to the firewall rule, and let's test again. And now the server responds. So what we need to do after that is just add that particular rule to the permanent, so it's persisting across the routes. So that's basically the way to configure access to the server. So as you can see, we have SSH in this zone as well. One quick way, for example, if we want to remove all SSH access, you do have a zone called block, right? So you could, in theory, you could say firewall-cmd if I want to remove SSH traffic, block, and then you add source and let's say that we want to block server 2 altogether, right? Add source, and then let's say 172.16.19.8/32. So that sources on that new block zone. So if I want to access it, then I'm still accessing it because the server is going to match the public zone, and it's part of the public zone, right? But we can always go to the public zone and then remove that source from there. Then 172.16.19.8/24, which is what we added there, and now connection fell, right? So just keep in mind that if you don't have a rule for a particular server and you want to block something fairly quick, you can just drop it on that block zone right here, and it's just going to get rid of it, right? So let's remove server 1 from the block zone, and we do 172.16.19.8/32. Okay. So right now, what's gonna happen is that server 2 doesn't belong to any zone, and it's gonna use the default default zone. In which case, if you remember, cmd get default. In this case, is work. So the rule is really not there on the work zone. So we say zone work list all, then we don't have a rule for port 85. Okay, so this is how to do basic firewalling, and how to work with how you can block and add services. Let's say that I want to add to my default zone something like HTTP, HTTPS, and some of the known ports. So let's just go ahead and do that, and this is very simple. The firewall-cmd has a very good list of services. CMD, then get services, and then you have a list of services there you can use, right? If you can see, there's quite a few of them, but you have some known ones like SSH, Telnet, and what it does, it has a list of ports already, usable for this kind of services. So if we wanted to add, HTTP service, you could just say, add HTTP, and it adds it to the running configuration, and you add a permanent, and then we add the permanent configuration, right? // All right. So now we have HTTP service available. Obviously, we're not running HTTP on port 80, right? So we are running HTTP on port, 85, which is probably not defined. So this is still not working, right? And we wanna, I wanna talk about a few things. So let me take a look at quickly what we have planned here. So we talk about zones. So we're talking about firewall rules, right? So the next thing is, I want to start talking a bit about, rich rules. And let's say that in this case, we're running the HTTP server on port 85. And the reason why we're running on port 85 is because we want to do some test, right? Before we make that site available. And we want to make some, want to allow only, right, traffic from server 2 to access server 1 on port 85, but then we also want to log those attempts to access port 85. So the way to do that is with rich rules. And what I'm going to do, I'm going to open the man page on this side, because we're gonna use it step by step, right? So we're gonna get used to use that man page. Okay, sorry, we had an interruption there. So let's pick up where we left off. I wanted to start talking about rich rules. If you remember, we're running a HTTP server on port 85. So what we wanted to do, we wanted to specifically allow just server 2 to access port 85, and not allow anybody else, right? If you recall, when we're doing firewall rules, and we allow that particular port, then that rule would fall into a zone, and basically any source that matches that zone, it will be allowed to access port 85. But there might be cases where we want a more granular rule sets, and for that you can use rich rules. And the rich rules are kind of complex, so that's why this is the way I use them. Again, I'm not saying that they're not other people who remember the whole how to do them very well, but I prefer to use the main page to guide me so I don't make any mistakes. So I have two tabs here. The first tab has server 2 and the first tab has server 1, but on server 2 I'm going to open a man page that's very important. If you recall, when we looked at the firewall.d main page, at the bottom there were a few suggestions. So one of the suggestions was the man page for firewall.d rich language. And the firewall.d rich language has the syntax and all the information on how to configure rich rules. And this is basically the here is the general structure of the rule. So this is how you set it up. You have the rule, the source, the destination, then you have services, port, protocol, log, audit, accept, and reject. But this doesn't tell you too much, right? Or at least it doesn't tell me a lot, right? So yeah, I have to do all these, but how to use them. And as you move forward, it's going to give you step by step on how to use all those options. And what we're going to do, we're going to use the rule that we're going to set up, and we're going to go option by option, and we're going to explain what all of them mean, and better you get a better understanding on how to configure these rich rules. So to configure rich rule, you do firewall-cmd, and then you do add rich rule, and then we add the rich rule within quotes. So we open quotes, and then we say rule first, and that's what's going to tell you that what comes after that is rule. So there's not really major meaning to that command, right? Now, as you can see here, the first step, it says rule, and then it asks you for family, right? The thing is, if you notice on Linux, every time you have a service that's listening on the network, you have a bind of an IP address and a port number. So if you in your system are running dual stack, the firewall has no way. It will basically have two binds. The first bind will be an IPv4 and a port number, and the second bind will be an IPv6 and a port number. Even though it might be bind to the 0.0.0.0 for IPv4, which means any interface, or the column slash 128 for IPv6. It doesn't matter. It doesn't matter really. The truth is that the firewall would not, won't know when to start filtering for this rule. So for that you need to specify the address family that you're going to use for this rule. In this case, we're working with IP version 4. So that's what we're going to do first. So we're going to define, the rule is for the family IP version 4. So that's the first step that we're going to do. So rule family equals IPv4. Now, the minute you start defining your rich rule, there's, you can't tab to all, to autocomplete. So, make sure you check your spelling and because very early, right? It's very hard to catch errors when you have a very long rule, right? So family IP version 4, and the next step is to define a source. And the source, the syntax is really source, and then you say not if you want to say if you want to negate what's coming next. In this case, we want a specific source, and then if you want an address, then you enter an IP address or a subnet address, and you specify the subnet mask. If you want a MAC, then obviously you enter the MAC address following, and if you want an IP set, then you enter the IP set. So in this case, what we want to do is we want to apply this rule to our server 2 address. So let's say source and then address, and then the address for server 2, which is source address equals 172.16.19.8/32. Okay, so we already have a source address. You can certainly define a destination. In this case, we don't want to define a destination. So if you don't define a destination, the file is going to assume that this is traffic going to any of its interfaces, right? The next thing is to define a service, and this is for services that are already predefined. So if you wanna apply this rule to something like SSH or something like HTTP, and you're using the default ports, then you can say service, right? Name, and here you add the service name, which would be HTTP or HTTPS or something like that. But since we're running HTTP on a different port, then that port is not part of that. It won't match that rule if we define the service name as HTTP. So what we really need to do is actually define a port. So in this case, we're going to enter port, and then port equals, and the port value, and then we specify the protocol, and then we make it TCP or UDP. In this case, the port value is 85, and the protocol is TCP. So let's go ahead and do that. So port, then the port equals 85, and the protocol equals TCP. Okay, so we have already the address family, the source address, and then the port and the protocol. So we're pretty much set to do this. There's some other options that you have here. You can specify a particular protocol, and if you want to just do the protocol and you don't want a port number, you can masquerade that traffic. You have some ICMP blocks, some ICMP types, and there is port forward here that we're going to talk about it later as well. And the same way as with the address, you do have source ports. But what we said initially is that we wanted to create a log, right? We wanted let's say that this is very critical traffic, and we want to keep on a log trail of that traffic. So the way to do that is using the log command, and this is the syntax right here. So the way to configure this is by saying log and then the prefix, and the prefix is just some text that you're going to add at the beginning of your log. And I like to add that text because that gives me an opportunity to identify that log, in the log file. Then here you can define the log level. Please keep in mind that the log level, the accepted values are down here, which is for emergency you have emerge, alert, critical. So this is how you define critical, which is crit, error, warning, notice, info, and debug, right? So what we're going to define it as just a notice, right? So it's we don't want to give it too much thought to the level, but just know that you can do that, right? And the next configurable is the limit, right? The next thing you can configure is the limit. So what that means is that if you have a rule that you expect it to be very active, you don't want to fill up your log with a lot of information. So you can limit the amount of logs that are sent to the log files, with this value here, which is rate and duration. And you can say something like, well, I want 3 per minute or 3 per second or something like that, right? So let's configure it this way, right? So we're gonna create a log and we're gonna give it a prefix that is gonna be HTTP 85, just to so we can identify it in the log file. And then we're gonna create a limit, right, in case we have too much getting logged. So we're gonna create a limit of no more than 3 per second or something like that, right? So let's go back and we say log, right? The next thing is prefix, right? Prefix equals, and then the way to enter the text in there is between quotations. So let's just do that as well. Let's say that we're gonna do HTTP 85, and then we leave a space after 85, so it doesn't concatenate the entire, this prefix with the entire verbiage of the log, right? And by the way, it's always a good idea to put quotes for all your values, and I find it, it's not going to give you any errors or anything, but it avoids any mistakes as well. So let me just do that as well. So we put quotes here. In the case of the log prefix, you certainly need it, because otherwise you won't be able to tell when the prefix starts and when it ends, right? So it's important to have it there. So the next thing you said we wanted was a limit, right? So we want to set a limit to how often we can write on the log. So limit, and then value equals let's say 3 per second, right? So let's close this between quotes as well, and then we define after that. Let's just keep going through the file. So now we already have our rule pretty much done. We can do audit, but then the next step and the final step is to define an action for that traffic. So what do we want to do? We want to accept it, we want to reject it, or we want to drop it, or we want to mark it, right? So let's accept that traffic, just to allow server 1 to access to allow server 2 to access server 1 on port 85. You can set some limits on accept as well. This is also interesting in case you wanna consider it. This is something that is done as a precaution. If you have a service that you know that you don't expect a lot of traffic for that service, you can set a limit of how often that service is allowed, right? In case somebody tries to do a denial of service attack, right? Let's say you have an FTP site, you don't expect clients hitting your FTP site more than once a minute or something like that. So you could do that in case an attacker wants to generate a lot of connection to FTP site just to make your server unresponsive, right? So you have that option here as well for your action, right? So the action, the only thing you have to do is just specify your action at the end of the rule. So let's go back and say the action will be accept, right? Accept, and then we close it with a quote. So to let the firewall know that this is the end of the RHCE rule, we hit enter, and if everything was spelled correctly, right, we should have a success here. So now that we have the rule, we test it. If it works fine, then we add it to the permanent configuration. So let's go ahead and do that. So exit out of here. So we're going to curl http 172.16.19.7 column 85, and that worked. So let's see if the rule generated a log. So if we tell, and let's do a -f just to see it, in action as well. Var logs, and then we do messages. Then we should have the rule there somewhere. So it looks like there was some logs that happened after we access. So let's try and generate some more another log. So if we go back here, all right, so I don't see the log there. So if we don't see the log there, it's probably matching some other rules. So let's see what's going on, right? Let's do some troubleshooting. All right, so firewall. List all. So we got the RHCE rule here, and this RHCE rule is applied for our work, which is our default. And let's take a look at the public zone. This is what's happening, right? So we have server 2 as one of the servers on the public zone, and the public zone is allowed on port 85, right? So let's just fix that. So let's remove this source out of the public zone. So firewall-cmd zone public, and then we remove source. Remove source, and we just take this one here. 172.16.19.8/24. Okay, so let's try that again. So we still can access the server, and if we look at the log, now we have a log that's called, it shows us HTTP 85, and then it shows, the MAC address, the source address is coming from. Okay, so we have destination, which is a server, and some more information in there, right? And then the destination port is port 85. So you will see that now every time that rule is used, then it's going to generate a log on your on your log file. Okay, so I want to give you some homework. I'm just kidding. Yeah, I'm just going to give you a suggestion. When it comes to rich rules, it's important that you try this out. It's important that you come out with some scenarios and do the same thing, right? Go step by step and and see all the things that you can do, right? Come up with different source traffic, blocking specific services to specific subnets or specific host and things like that, right? And try it out and do it several times so you're very familiar with it, and so you can you get used to be very fast at configuring these rules using the man page. I strongly recommend you to use the man page because that way you avoid any errors. Okay, so let's move on, and the next thing we're going to talk is about masquerading. Masquerading is also known as network address translation, and in some cases it's referred to as port address translation as well. It's really port address translation. The thing is that when you have a private IP addressing, normally when you use IPv4, your internal host, they have a private IP address, either class A, B, or C. Class A, which is a 10.0, whatever, 0.0.0, and then you have the class B, which is 172.16, or from 16 to 31, and then the 0.0.0, or the class C address, which is 192.168. So those private IP addresses are not routable on the internet. So one method that's used for that traffic to make it all the way out to the internet is to masquerade that traffic and do port address translation. So basically, every time your host needs to go out to a network that is public, then if it's coming from a private source, if that traffic is masqueraded, it will remove the source address and then replace it with the firewall's public address. That way traffic can come back, and it would use the ports to know where to send that traffic to. And there are several things that you can do with this. So I'm going to give you two main scenarios. It's really very simple, but the reason why I'm giving you two scenarios is in case you want to get granular as well. You can do it using your add masquerade command using firewalld.d, and what that's going to do, you can masquerade an entire zone. If you remember, let me just take a look at firewall-cmd list all. We have the zone work as our default zone. So let's say that all the traffic that hits this server and wants to go out to the internet or something like that, we want it masqueraded. So if you see here, you have the option of masquerade as no, right? So the way to set that option to yes is by doing firewall-cmd, then add masquerade, and that's it. So let's take a look at the configuration, and now we have traffic masquerading. So that's really all there is to it. The next thing you just need to remember is to add it to the the permanent at the end, just to make it persistent, right? So if there's a sorry. At the end, just to make it persistent, right? So you wanna make sure that if this when the router reboots, is going to keep that configuration. So let's take a look at the configuration that we have right now. So we have the reach rule, and then the traffic is masqueraded. To remove it is basically the same thing. So you remove masquerade, and that removes from the permanent configuration. And if you want to remove from the running configuration, then you just remove permanent, and that's it. So let's take a look at the configuration that we have right now. So we have masquerade, no, right? One way to be very granular is to use a reach rule. There might be some occasions where you don't want every host on your network to be able to go out to the internet. So let's say that there's only a subset of your network that can be translated into a different translated to go out to the internet, and you don't want the rest to use this file to go to the internet, right? Maybe because the rest is using a proxy or something else, or maybe they just don't have access to the internet. So you can do that by using a reach rules. And again, let's go and use the man page again. So because I want you to get very used to using the man page for reach rule. So firewall the rich language. Okay, so the rule starts the same way. So two important parameters are the rule family, which is going to be IPv version 6, and then source, and you define the source address, right? So we are going to allow we're going to tell this firewall to only allow server 2 to be masqueraded out to the internet. Then obviously you don't have a destination or a service or a port or a protocol or a CMP block. The only thing is you have the option to masquerade that traffic. And then you don't want any action of block or reject or anything like that, because you're just doing a network address translation for that traffic. So you can do that using reach rules, and let me show you how to do it. So firewall-cmd, add reach rules, then we say rule family equals IPv4, and then source address, and we enter the address of server 2, 172.168.19.8/32, and then we tell the firewall to masquerade that traffic. Sorry, and a typo here. It's not family, it's family. All right, and that was successful. So firewall cmd list all, and as you can see, we have another reach rule that's telling the firewall that any traffic coming from source 172.168.19.8. I'm sorry, this was supposed to be 16. So I'm going to show you how to correct it in a second. So to masquerade it. So I see that I made a mistake here in the IP address. So let me just correct that. The way to correct that is just by removing the reach rule. So that's also very simple. So you just up arrow all the way to the rule, and we don't want that rule. We want a different rule. So instead of add, we remove. And let's take a look now. The rule was removed, and let's correct it, right? So add reach rule family IPv4, and then the source address is incorrect. So let's fix that one. 172.16.19.8/32 masquerade. And we're back. All right. So let's verify what we have. So we have it already configured there, and the IP address is correct. If we want it on the persistent configuration again, we just up error and add permanent at the end, and that's it. So that's really all there is about masquerading, right? So these are the two ways to configure network address translation for if your server is acting as a firewall. But obviously, if you're using network address translation, that means that you're not routing. So incoming traffic really cannot get to your service internally. So if you have something like a HTTP server or something like that internally, you want to create a pull forward rule. So whenever incoming traffic goes on a particular port, to forward it to a specific destination. But port forwarding is not just used for that, right? Port forwarding can be used also to forward specific ports directly to your own server, right? So let's say, and I'm going to give you an example, and then I'm going to use that example to do that configuration in this case, right? So let's say that I want to forward port 8585 to port 85. Let's say that I have an application that is pre-configured to use port 8585, so I cannot change the application, but I changed the default port on my web server, and I want to forward 8585 to port 85. If you see right now, let me just confirm here. If I do curl http //localhost column A585, that the connection is refused because that obviously that port is not active on server 1. Sorry, this is localhost. Let me just do server 1, right? 172.16.19.7. So why it says no route to host, right? Because that port is not available on that server. So there's also two ways to do port forwarding. The first one is using firewall-cmd, and there's also the more granular way to do it using rich rules, and we're gonna get there in a second. And we would do the same rule both ways, right? So for port forwarding, again, this is one of those configurations that you really need the man page because it's very, very complex. So let me show you the man page for firewall CMD, and in there you have, let me just take you there quickly. You have the syntax for port forwarding, which you will see, and I showed you earlier as well. It's very, very long. So let's just get there. And just copy it. So here we have the way to configure, which is add forward port, and then you have all these options here. And we're going to talk about them in a minute. But for now, let's just grab all these and then copy it and paste it on the other side. All right. Okay, so I'm going to say firewall CMD, and then I'm going to add a forward port, and let's go one by one here, right? And then I add a forward port, and then it tells me port, and then it wants a port ID, right? And as port ID, I'm going to say I'm going to forward port 8585. The protocol that I want to use is TCP, and then we have the rest is really optional, but let's say that we want to forward it to port 85, which is what we want to do. Let's take everything else out. 85, and then we can tell it to address if we want to send it to a different host. But since what we really want to do is send it to to this server itself, then we don't need to enter the to address, right? So we have port forward, port 85, protocol is TCP, and then to port 85, and that should be sufficient, right? So that's succeeded. And if we go back to a server and we retry to curl into port 8585, you will see that now we have access to the web server, which, if you recall, is actually running on port 85 on this server. Okay, so let's the way to remove it is same way. So instead of add forward port, you remove. And there is a way to do it using rich rules, and let's do that right now. So let's add a rich rule, and then let's go to the main page again. So it's firewall-d rich language. Firewall-d rich language. Can't find it. Let me see if I firewall-d rich language. All right. It looks like I had a typo there. So let's go ahead and do a port forward using a rich rule. So obviously, port forwarding, you know, we need to define the family as well. So that's the first thing that we need to do. So let's go ahead and do it. So rule family equals IPv4. So that's done. The next step is we don't need source, we don't need destination. Although we might specify the port forward rule for a particular source, but in this case, we just want to make sure that anybody going to port 8585 can get to port 85. So masquerade, let's go to forward port, and here's the syntax, which is a lot simpler in my opinion. I mean, feel free to disagree, but I'm just gonna copy all this and paste it on the other side, and then I'm gonna enter the values, right? Paste. So what do we got? Let's go one by one. So port forward, the first thing is the port value. So I want to forward port 8585. The protocol, here it tells you TCP or UDP. In this case, it's TCP. And then to what port do I want to forward it? I want to forward it to port 85. And then obviously, if you want to send it to an internal server, in this case, we want to send it to this local server, so that's it. So we have a rule family IPv4 forward port 85 protocol TCP to port 85, and that worked as well. If we go and test now, then we can access the server. Okay, so that's it. So today we took a look at port security. It was a very long video. I apologize for that. Hopefully you go through it several times. But we talk about the toolkit. If you know by now, the toolkit is critical to be able to do port security effectively. So we had some discussion around SE Linux and port labeling. We introduced the host.deny file and the host.allowed. We didn't talk about the host.allowed, but it's basically one file is used to deny, the other one is used to allow. A lot of administrators use the host.allow file more than the deny, because they can add the deny statement on that file anyways. But then we had some discussion around firewall-d, zones, and then firewall rules. And we talk about rich rules, and I show you how to configure those rich rules and how to find guidance as well for those. Then we discuss masquerading or network translation and port forwarding. So now the next thing is a lab. So I have a quick lab here proposed for you, so you can test your skills on your understanding on this video. So the first thing that I'm asking you to do is to configure a web server to listen on port 82. When you install your server for the first time, port 82 will not be on the list of SE Linux labels, SE Linux ports that allow for you to run your HTTP server on. So this is going to require for you to configure the right label to add 82 to the HTTP to the SE Linux ports that are allowed for HTTP, right? And then I want you to change the default zone to work. And then I want you to allow traffic in zone work to port 82. And then configure a firewall to use network installation for zone work, which is masquerading. And then forward port 8080 to port 82, and then log the traffic with a prefix HTTP 8080. And then make it information and limit it to 3 per minute. Alright, so I hope this video was informative, although it was very long. And I'll see you in the next video.